Okay, there we go. I thought what I would do is I looked over the Khan Academy style questions from yesterday because I wanted to make sure to see if there was some style questions that you guys were given that I didn't cover fully, because I mainly went over the major topics. And as I looked them over, I know in the past students have been confused over what I have labeled as question 2 and 3. Question number 1, I wanted to put that up there because I didn't cover it at all, but I think a lot of you probably figured it out. But I wanted to put it up there just to make sure to get it covered. And I'm trying to come up with ways that I can kind of make my lessons more efficient, because I'm going to have to try to cram things into an hour. And I don't know if what would work best is, like today, I'm just going to kind of experiment by taking some of the questions out of Khan Academy for today's material to see if that would make it go quicker. We'll just try to experiment a little bit on how to get things in. So, question number 1 up there was from the homework assignment. And it says, what's the best estimate for g prime of 18 we can make based on this table? Let's go with, who should we go with? We should go with Connor. Connor, what I was hoping you could tell me, probably the worst circle ever there, what does g prime of 18 mean? Because that's kind of key for this whole problem. Sure, that's a great way of saying it. So this is the derivative of equation g at x equals 18. And what it's basically asking you to find is the slope at x equals 18. Now it says what's the best estimate. So the way we're going to estimate this is you find 18 on the table. 18 would be right about there. I'm going to take the 2 points that are around 18 and use that to find the estimate. So it's basically just us finding the slope between 2 points. This notation here is where I think some people get confused on it. That's why I wanted to focus on this question. So this is going to be the point 1687 and the point 1996. And to find the slope between those two, so g prime of 18, approximately, so that's our estimate. So g prime of 18 is approximately 96 minus 87, so y2 minus y1, over 19 minus 16. I should be able to do that in my head quickly. 9, 3. So the best estimate for g prime of 18 would be 3. And absolutely feel free to ask away if there's something up here that confuses you. Okay, Connor, can you help me out by picking, I don't know, pick somebody else in the classroom. Matthew. Wait, what? Oh, nice. Matthew wasn't even in the meeting. Okay, Matthew. Look at that. You got called out. Okay, Matthew, what I was hoping you could tell me is yesterday, what was the equation we used to find the derivative? Yep, absolutely. Well, I mean, yes and no. What you read off was great, but you forgot the part in the front. So it's the limit as h approaches 0. No, I mean, if you did that off the top of your head, that's great. I was expecting you just to look it up and read it. Okay, so that's what we focused on yesterday. And I use that one because this is the one that's used for 99% of the derivatives. Now, when I looked in the Khan Academy just to look over the questions to see what was covered, they also covered the alternative form of a derivative at a point. So, alternative form to find a derivative. God. Now, this formula only works at a specific value. And it's the limit as h, back up, as x approaches c of f of x minus f of c over x minus c. So this top one is the main derivative equation. Okay? The second one is an alternative way to find derivative at one spot. So the answer to this one would always be a number. I'm not a big fan of this second equation because it hardly ever gets used, and it's not very useful. But it was covered in your homework, so I want to make sure you know how to do it too. Matthew, can you call on somebody else that's not in the classroom? Basically, I don't care who you call on. I was just randomly picking. Eric. Eric, is there... I don't know how to phrase this. There's two main differences on these, Eric. Can you identify the two main differences? Or a main difference? Which might be difficult. I don't know if it is or not. Okay. So, I mean, yes. What I'll kind of focus on is the denominators. Okay. The tops of the equations, definitely the x plus h is different. I mean, that's obvious as well. But on the denominator, the one way that you take a derivative just has an h on the bottom. And then the limit is at h going to something. So it's kind of like h is the focus. If you look at this second one, this one has the limit as x approaches a number, because c is representing a number. And it doesn't have to be 0. And then the denominator is x minus that number. So on the left, I've got question 2 and question 3. And for most students, when they get these questions, they have a really hard time distinguishing between the two questions. Uh-oh. There we go. Got my mouse back. So I wanted to point out where I focus on to determine which equation is which. So if I'm looking at question 2, this is x approaches e, and if I look at question 3, this is h approaching 0. So if I'm trying to determine how to match these problems up, that's what I focus on. Okay, so this question number 2, I see as x approaching, or x minus e on the bottom. Wow, that means it's matching up with this alternative form. And then the question you're going to be asked is, what was the function at what x value? Okay, that's what you're trying to answer on both of these. What was the original function and what is the x value? So this top one, the x value that it's focusing on, that number right there, e. The function is the one that's shown, ln of x. This 1 right here is what can throw you off. This 1 is ln of e. But if it can be simplified, it will be simplified. So you should focus on the parts that don't ever change. Now, when I'm looking at question 3, I know that it's going to match up with this top one. So the top one is the limit as h approaches 0 of f of x plus h minus f of x over h. Well, I need to identify two things, the function and the x value. Does anybody know the x value right away? Yes. So the x value is going to be 3, because that's the number I spot in place of both x's. So f of x plus h, f of x. That number I can spot in both locations. And then the x plus h, it's obvious right here is plus h. The x plus h was in the power, so the equation that was being used was 2 to the x. These are ridiculously simple once you know what you're looking for. If you don't know what to look for, they seem very complicated. You're not actually doing any work in them, you're just identifying what information is there. So you guys had a handful of questions on that yesterday. I saw about half the class already did their work, so that's great. So I have a feeling some of you already kind of know these problems, but I definitely wanted to cover them because they're different, and they don't feel like what I was explaining yesterday. How about from 1, 2, and 3? Does anybody want me to cover or re-go over anything that's up there from yesterday's work? Okay, wait. Say the info again. Yeah, no, I heard the question. You started reading off an example. So these both actually find the exact same information. I think when you read this info off to me, I don't think you meant f prime is equal to 4. I think you meant the x. You're supposed to find f prime of 4. Okay. Okay. Yeah, so that was a little different than what I wrote the first time. They both can be used. So I guess the difference for you is you have a multiple choice question that you're trying to look at. And if you're looking at the multiple choice questions that are there, you focus on that. You can use either one. No, you can use either one. So if I took this information and I filled it out for the top problem, I would say the limit as h approaches 0 of square root of 4 plus h minus square root of, oh shoot, I can't write over there, square root of 4 over h. The bottom one, if I filled out the bottom equation with that same information, would be limit as x approaches 4 of square root of x minus square root of 4 over x minus 2. They both would give you the same answer. They're just done differently. Well, then you pick the bottom one. If this was a free response question, both of these are correct. They get you the same answer, so both are correct. They're variations of the same problem. I don't ever use the bottom one because it doesn't usually give you answers, because the bottom one is harder to solve. The top one I've usually found easier to solve, but they both give you the same answer, so you can always pick either one. It's just obviously if it's multiple choice, you pick the one that it fits. I mean, I guess that's why I call it the alternative form of derivative at a point. The top equation works for finding a derivative, which is an equation. A derivative can find you a slope at any spot. The bottom one can only find you the derivative at one x value. So the answer would always be like a single number. The top equation can be used to find a derivative for the all x values, or a derivative at one x value. The bottom equation can only be done at derivative at one x value. Now, all the problems you guys had yesterday were mainly focused on at one x value. So that's why they interchanged them. Okay, well, why don't I kind of move on to today's stuff, which actually doesn't take that long. So that's why I felt good about going over some of the work from yesterday. I thought it would be helpful for you to kind of have be able to talk about derivatives a lot since they're new. Okay, continuity and differentiability, how they are related. Differentiability, as a reminder, is another word for derivative or slope. So, I'm not great at grammar, like I tried to mention yesterday. Essentially, how you generally are going to see these used. Derivative is often going to be used as almost like a verb, like doing the action. Differentiable or differentiability is almost like the adjective or description. And they all mean the same thing. Continuity, we've done, talking about a function being continuous. Well, the key part that we're getting out of here if a function is differentiable at an x value, it must be continuous. So, you're going to be given some situations where you're going to be asked to look at the continuity and or differentiability. So, the easiest way for us to start is from pictures. So if you are looking at a picture, you're going to need to be able to identify any locations where you wouldn't be able to find slope. So if you can't find slope at a spot, then it wouldn't be differentiable at that spot, at that x value. So that's differentiability when they use that word. Now, the first thing you're going to focus on is you're going to look to see if there are any spots where your function is not continuous. If your function is not continuous, maybe I should write these down, that would be smart. I probably should have written discontinuity, but I'll just write non-continuity. So first, you're going to look for any locations that are not continuous. Now, if that's the case, automatically, not differentiable. Okay? Next, there are going to be other situations where a graph is continuous, but you can't find slope. Now, the first thing that should come to your mind for that is a line that is straight up and down. That's an undefined slope, but yet it is continuous. So I'll write a vertical line there, but that's what that means. So look for any vertical lines or sharp points. Now, we haven't run into this situation yet. If you have a sharp point on your function, probably the easiest example for you to think of is absolute value. Absolute value has a sharp point at the tip of the V. So if you think of slopes, well, obviously the slope coming into that point is normal and regular, and the slope coming out of that point is normal and regular. But the slope directly on that point doesn't have an answer, because for you to have a slope, I'll write this in technical terms. To be continuous, the limit approaching the value from the left has to equal the function value, has to equal the limit approaching the value from the right. So we talked about continuity a while ago. Differentiability is the same except for derivative. Differentiable. This is how AP is going to have you prove things. So if you think of an absolute value, the slope coming into absolute value of x is -1. The slope coming out of that tip is +1. So that tip is not differentiable. Jesus, these words. Differentiable. That tip is not differentiable because the slope coming in and the slope going out are different. So on the left-hand side of that tip, on the right-hand side of that tip are different. I know I just crammed in a lot of info there. I'm hoping you can read that okay. But I thought it would be helpful if you had things written down because you guys are able to use your notes for everything. Okay, what I wrote in purple is what you're actually going to do. What I wrote in red is kind of like how you have to prove or verify things if you have to write down something. but the purple is what you actually just look for. So I've got some examples here that we can do together. So I'll give you guys a minute if you want to just sketch these really quick. Obviously, you don't have to make a nice graph. You just want to highlight like important parts on these. And I took these directly out of the homework, so maybe you'll get lucky, and these will be the questions you get in your homework. That's why I said I'm trying something different today to see if it goes more efficient, to kind of have things written down for you already. Matthew, I think you called on somebody, didn't you? Yes, you called on Eric, right? Eric, I think you went last. Is there somebody that had... Oh, I suppose you don't know either. Is there somebody we haven't called on for a long time? I think we called on everybody yesterday. Why don't you just call on somebody you want to call? Okay, Lila. See, I like passing the blame on to you guys. I make you guys make all these choices. You can get mad at each other. Okay, Lila. If I'm looking at this first picture, first thing we want to do is identify if there are any discontinuities, so any areas that are not continuous. Correct. X equals 0 is a discontinuity, so automatically x equals 0 is not differentiable. Perfect. Okay, so if we put these in terms of multiple choice, you guys are going to get questions where it'll give you a specific x value. And it'll say, at x equals 0, discuss the continuity / differentiability. Well, you're going to get 4 choices. Not continuous, not differentiable. Not continuous, differentiable. Continuous, not differentiable, continuous and differentiable. The one choice you can never have is that it can't be differentiable but not continuous. So you're going to be given those 4 choices all the time, and I want you guys to know that that's never a possibility. To be differentiable, it has to be continuous. Okay, looking at this second example. Lila, who's going to help me with this second example? Connor was the first person we called on today. That is very unfair. Okay, so Lucas. Lila called on you because you're right next to her in the alphabet. If I'm looking at the second picture, is there any areas where it is not continuous? No. Okay, so then the next thing we look for, is there any areas where we couldn't find slope, where we have vertical lines or sharp points? Yeah, it technically does say it above it, but I'm sure it's written really small for you guys. It says there's a vertical tangent at x equals -4. Okay, so x equals -4, it is not differentiable. So if I were to describe this location, it is continuous but not differentiable. I'm just going to start abbreviating as the words are getting too long. Okay, third example. X equals 2 is going to be not differentiable. It's continuous everywhere here, but this is a sharp point. Okay, Lucas, I'm going to give you a job ahead of time before anybody knows the actual question. And I need you to pick somebody who's going to, we need to choose somebody who's going to be a representative of the class, who is going to be like a, like a ringer, who guaranteed to get it right. And this way we're putting major pressure on this person. Or did this just put too much pressure on choosing that person? Okay. Okay, Julia. Julia, I can help you out if you want to. I was not trying to gang up and say you have to get it right. Okay, so we've got a picture here. Same question. Find all the x values that it is not differentiable. I was just, you sounded like you were questioning yourself. Okay, here's a pro tip. You guys should always sound confident, even if you are 100% wrong. Sound confident. The worst is when you guys, as a teacher, it blows my mind that people will answer questions on the test and then put a question mark by it and say IDK. And it blows my mind that you want to get credit for a question that you're saying that you don't know how to do. So fake it if you have to. Have confidence. It will help out your decision-making abilities. Okay. Julia, call somebody else. Kelly. You guys basically just called on each other yesterday. Okay, Kelly. Was she right? Okay. Why those two numbers then? How's that? Good. Good. Perfect. Perfect. Okay. Now, technically there would be two other spots, but I know they didn't intend for that on this picture. The two other spots would actually be right here and here, because you have to have a slope on both sides to be differentiable. But it wasn't asking about that. Like that would be like super technical. And this is a multiple choice question anyway, so those weren't choices. But very good. Very good. So if you guys were able to kind of identify that on your own, nice job. Now we're going to move to our last example of the same type of question, but now we don't have a picture. So we're supposed to try to identify continuity and differentiability, but from just equations. That's why I thought it would be a really good idea to start with pictures, so that you can try to visualize in your head. Ola. Ola, can you help me out here? Do you remember, we had these in Unit 1. Do you remember how to determine if they're continuous? Good. Perfect. Perfect. Okay, so to check for continuity, we are going to plug 2 into both of them. So 2 squared plus 1 equals 5. 2 minus 2 squared equals, not 5. This is actually a terrible example to start with. I should have started with the other one. 2 minus 4 would be negative 2. This tells me it is not continuous at x equals 2. Ooh, almost unplugged my headphones on accident. Caitlin? How do I determine if they are differentiable at x equals 2? What was the equation from earlier? Oh, you mean from the very top? Oh, perfect. Nice job. That was really good. You did that kind of off the top of your head. I'm impressed. So differentiability means we need to determine if the slopes are the same on the left and the right. Well, you're going to have to take these two equations and find their derivatives and plug in 2. Okay? Now, I will do that in a second. Jack, can you tell me why I don't even need to do this? Oh. Yes, I don't even need to figure that out for this problem. And that's okay if you can't think of it. No, that's all right. Haley, do you think you know why we don't even need to figure it out? Like, why do I already know the answer? Perfect. So the fact that we already figured out it's not continuous at 2 automatically means no matter what we do, it's not differentiable at 2. Even if those two equations have the same slopes coming in, it's not differentiable because it's not continuous. Now, we're going to pretend that we didn't know that. And I'm going to go through the work on how to do this with you. So x squared plus 1, the derivative of x squared plus 1, I'm just going to give you the answer. This is the notation that shows that I'm taking the derivative of x squared plus 1. The derivative of x squared plus 1 is 2x. The derivative of x minus x squared is 1 minus 2x. So if I plugged 2 into both of them, I still have different answers anyway. 1 minus 4. So this one's just kind of a big mess where all of the information is different. Now, if I, basically here's what I did. If I went through and did this problem, I would have gotten equal to 2x. So like if I would have filled this out, and you can absolutely see that these get to be a huge pain in the butt because they're so slow. And I'm telling you right now, we're not doing them for very long. So very soon you're going to learn how to find derivatives in your head without having to do this limit work. So just be patient. Okay, I would like you guys to try this one on your own. I will give you the derivatives. Let's put Melanie in charge of continuity. And what the heck? My mouse is messed up here. Let's put Kate and Luden in charge of differentiability. So whenever you two get to the part of the problem you're in charge of, why don't you kind of speak up and tell me what to do, or tell me what to write. Okay. 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 So because of that, not differentiable. Perfect. Not differentiable at x equals 2. Okay, nice. Melanie? Would you like some assistance? Or do you... Okay, you think they are continuous? How come? We'll put a question mark there for now until we figure out if that's true or not. Alyssa, maybe you can help her out, because I think she's probably trying to type that out. It's probably horrible to type out. Oh, all right, so we've got two possibilities. What did you try to do? -4. Oh, so Melanie did the same thing, but she got different answers. So if I plug 2 in, I need to square it before the negative. Something tells me you did the negative first. Yep. Yep. Okay. But correct idea. Okay, so 2 squared is 4. -4 plus 6 would be 2. And the bottom equation, 3x squared minus 10 would be 4. 12 minus 10 would be 2. So it is continuous at x equals 2 because they are the same. Okay, nice job. I mean, good. You both had the same ideas. So that's good. All right. That pretty much covers everything for today. I mean, today the most difficulty for most people on today's topic is just understanding what differentiability means. The actual work isn't usually too horrible. However, you guys could probably tell that a majority of the work that you're going to have to do is... Okay, it's not written. A majority of the work that you're going to have to do is actually taking the derivatives. That's what's going to go the slowest. These went quite a bit quicker because I just gave you the answer. Oh, actually, this is a good point. If you guys are doing work on your own at home, which pretty soon will be everybody, I know Khan Academy, it'll tell you when you do things wrong and things like that. But there are actually quite a few websites that you can go to check your work. If I remember correctly, I don't think Photomath does Calc. I think it only does up through Algebra, if I remember right. But maybe they've updated it. I don't know. The main one that I've used is wolframalpha.com. And they also have an app that you can just download to your... Oh, wait. I think the app was like $7. Maybe they've changed it to free by now. I don't know. The website is free if you just go to the website. And you can... Like, if I want to just check my derivative, I can write derivative of 3x squared minus 10. And it will give you the answer, which would be 6x. And I believe it'll show you the work. I don't know. Sometimes they make you pay for stuff, but this one's changed over the years, so I don't even know if it shows the work or not anymore. But you absolutely can use this website to check your work. Otherwise, if you Google, there's a website called like Derivative Finder or something like that. I don't remember what it's called. If you Google that, there's websites that do it for you as well. And they'll show you the steps. So, if you guys are doing the limit problems and you're not sure if you do them right, you can certainly go there and use this to check your work. Okay, let me stop here.